Good afternoon. Welcome to Foundations of Engineering and Architectural Design. My name is Mr. Shea. I'm the teacher for this course, and we'll just get right into it. So, in Foundations, you're going to be introduced to the engineering design process, which is a process that's outlined here that we use to come up with ideas for projects and make sure that those ideas are our best ideas. Um, Something that if you took eighth grade or seventh grade STEM, you probably were introduced to this process as well. But just to kind of reiterate it and show that we continue to use it in everything that we do for our projects. We apply science, technology, engineering, art, and math to hands-on projects. So a lot of times in this class, I'll hear students talk about this is where we use these math formulas and things like that. Um, this is where we use those science concepts, that kind of thing. And it's true. We do end up using a lot of this stuff. And for me, I think it's a little more fun, a little bit more relatable because it's concerning a project that you're working on, something that you're interested in. So it kind of makes more sense than to just be in a regular math or science or technology class and not really seeing directly where that these things can apply, but instead we get to apply them here in this class. We will learn a number of different engineering and design principles related to drawing on the computers. We'll also use a bunch of different programs such as AutoCAD that we'll use for drafting, Inventor, which we will use for 3D modeling, and Revit that we will use for architectural design. We also have a program called White Box Learning that we will use when we work on engineering design, but that's a little bit different than these. The concepts that are provided in this class for your study, they provide a great study for engineering, architecture, pretty much any type of pathway into STEAM or STEM. But it's also really good just for other courses as well. Engineers, architects, designers are commonly thought of as good problem solvers because they develop those skills. It's not just something that you're inherently born with, it's something you work on. So that's kind of the reputation that architects, engineers, and designers have are as problem solvers. So it can be seen as applicable to a number of different professions. So the way this class breaks down by marking period is first marking period, we focus on AutoCAD, which is that drafting program. We learn the basics of engineering graphics, essentially how to communicate through our drawings and through writing. So we can't always be in the place where our designs are being built or constructed. So we need to be able to communicate through other ways, and that's through our drawings and through our written words. In the second market period, we build off of that and we do an architecture project. We spend the whole market period doing a project on Revit, which is a little bit different than CAD, but uses a lot of the basic concepts. Same thing when we get to marking period 3 with Inventor. That's for the 3D modeling program. So we do like a cube design project. We also design a skyscraper in the third marking period using Inventor. So we get to use that to model 3D concepts. Then finally, in the fourth marking period, we do a hands-on project. We do the CO2 dragsters. We'll end up racing them in the hallway, typically outside of the auditorium by the caf there in that hallway. And that's a fun project. We do that in the fourth marking period. All right, so getting more detailed into the AutoCAD work. AutoCAD, we start off by doing some CAD drawings. So we start off with the one in the top left there with the squares. And eventually we make our way through the marking period and we get to a level, you get to a level where you can complete the drawing on the top right. We do have 2 or 3 drawing quizzes, and we do 2 to 4 small projects in AutoCAD as well. So these are some of the other drawings that we get to, the isometric drawings where we're seeing multiple views at the same time on the same sheet. And then we get into some curves and some three-dimensional drawings as well. This is one of the projects that we do. It is called the Interlocking Shapes Project. So you are kind of left to your own device to create an assortment of shapes that interlock with each other. So if you look at any of the shapes, Like if you look at some of the circles, as you make your way around the circle, you see that it goes over some objects, but then under other objects. There are a couple of criteria for this project, but that's the main one. You want to make sure that your shapes all interlock like a chain. And from there, you can come up with any design concept that you want, whatever shapes you want, whatever colors you want. The next project that we'll work on is an isometric text project. So this goes along with the isometric drawings, where students will take a word or a short phrase and they will create that in this kind of box fashion, kind of to make it really bold and stand out. And again, you get to choose what kind of words you want to use, and you get to choose the color that you use. So these are kind of used for like big statements, like the one like in the bottom right, you see it says obey. So it's kind of like something like that, something big, something bold, something that you want to convey. And then finally, the last project that we do in AutoCAD, a lot of times this might spill over a bit into marking period 2, but we create your own type of world similar to what you see here. So this isometric world where you've got all these different things going on, but they kind of have this plain background. And in some cases, they kind of fade into the background. Others, they kind of look like their own standalone object. But again, you have the freedom to create these worlds within a few criteria. And it's always great to see what students can come up with for those. Okay, here are a couple other examples of what that might entail. They use water. They have different kind of roof styles. There's windows, there's stairs, there's platforms, there's walls. There's all different things that are incorporated in here. And a lot of students even choose to kind of have some kind of like optical illusion so they can see, if you follow like the water as it travels around, it might not always make sense how it's just kind of always falling into itself kind of thing. It's kind of interesting. In the second marking period, we get into architectural design. So we will get to the very basics of designing a house. So we'll cover topics like the basic home design, primary design considerations when you're doing a house. We'll talk about floor plans, site plans, roof designs, and elevations, which are really essential when you're designing any type of building, specifically a house. Okay, so we will cover those types of drawings. We will do this project in Revit so that it's a 3D building modeling software. So what's really nice about it is like if you, for example, have your building and you move a wall, you move it over 3 feet, the program will coordinate that so it does that on the floor plans and on the elevations and any other plan where that window is seen. In AutoCAD, it won't do that. You have to go in and physically move each one in each of the drawings. So that's a nice advantage of Revit, that it kind of coordinates it all and creates this 3D model of it. And you can take your drawings right from that. So the project that we do is called the Family House Design Project. I tell you about the basics of who the family are, and then from that, you need to design the house that fits them the best. So then you end up producing floor plans, elevations, a roof plan, and a site plan to show how the yard would look. There are also a couple of renderings that are automatically created because it is a 3D model, so there are those as well. In the third marking period, we get into 3D modeling and printing, so we'll have some lessons about that. And we will use the Inventor software, which allows us to more easily do 3D objects. So as you will learn when you do AutoCAD, when you are creating these multi-view drawings, like you can see in the bottom left there, when we create those in AutoCAD, you actually have to physically draw each drawing. If you do this in Inventor, all you do is you create the 3D shape, and then the program itself will draw those drawings for you from the shape. So in this case, this example in the bottom left there, we've created that shape that you see in the top right corner of that drawing, the shaded drawing. Somebody created that, and then from that, the drawings were created by the program. So again, it's really nice. It's more convenient than AutoCAD, and it helps you to create multiple drawings much more quickly because you're creating the piece or the part. Just like in AutoCAD, there are some drawing quizzes or part quizzes that you will do. You will do a couple projects as well. So we start off with a 3D printed keychain. Most of these are pretty standard. They just kind of run you through a couple of the standard commands that we'll use. and then you can change up what's the wording that's on there. You can choose your own words. You have some options to change a few things, but this project is pretty standard. It's just kind of like you go through it, you do a couple of the commands just so you get used to the program. From there, we move on to a cube puzzle. And that project is you create a puzzle that's just like a brain teaser where you have to put pieces together to form a cube. And then after that, you get into the skyscraper design where you can design your own skyscraper and you have the freedom to design it however you want within the few constraints that you are given. In the fourth marking period, we move on to the hands-on part of the class, the engineering design part. We do the CO2 dragster project, and that lasts the entire marking period. So we focus on the project-based learning, the computer-aided design, hands-on work, kind of the things that we've been doing all along, except for the hands-on work. Open-ended assignments. So essentially, I'm telling you to design a dragster. I'm not telling you how to design it. So you get to figure that out, and you get to design it the way that you think is best, following that engineering design loop to create the best project you possibly can. We design and build these dragsters on the computer, and then once they're done on the computer, the students will actually recreate them in the physical world from a block of wood using band saws, drill presses, sanders, Dremel, sandpaper, and paint. You can paint them any style that you want. And then we will race them in the hallway in a head-to-head competition to see who is the best in the class. Once you pass foundations, you pass foundations of engineering, architectural design, and you get a recommendation from myself, you can then go on to any one of the other three classes. So there's engineering graphics honors, which is what we do in the third marking period, where we're designing projects, we're 3D printing them, we're designing prototypes for designs, we're printing those, testing those. Then there's architectural design, which we spend each marking period designing a new house, different kind of house for different kind of family, different kind of clients. So they're all different projects, but they all go over the entire marking period as we learn more and more about the details of designing homes and designing buildings. Engineering design and robotics is the hands-on course similar to the dragsters, where students will do hands-on projects for the most part. For generally the first marking period and a half, we focus on doing VEX robots and doing VEX competitions. Then we start to transition into other engineering design projects. There are also options to do other robotics competitions as well. All right, we're going to have a couple summer assignments, nothing very major. You'll see these come out in August. There'll probably just be some class rules, some type of online video such as this going over the class rules and the presentation, and then there'll be a quiz on that to make sure that you paid attention at the end. This is kind of to make sure that we don't waste our time in the beginning of the year going over the class rules and things like that. We can jump right into our assignments. So on the very first day, we'll kind of just go over a couple things, make sure that we hit on some important topics about the class rules and procedures. And then on the second day, we can just jump right into our first project and first assignments. Again, my name is Mr. Shea. If you want to get in touch with me, that's my email there up on the screen, tshay@westx.org. If you want more information about the class that I've just described or look at some of the other classes, you can go to my website here. It's sites.google.com/westx.org/Mr-Shea. Thanks for watching the video. Be sure to fill out the interest survey that's also posted in Google Classroom. Looking forward to seeing you in September.